Hey guys, welcome to my class Python for Beginners, and this is lecture number 17, and this is the last of the lectures on classes and objects, and today we're going to talk about operator overloading and inheritance. So let's just dive in and open our file 15.py because we're going to be using that file again. Oh man, okay. Sorry guys. These files 15. Okay. So this class had the definition of the point class and the rectangle class. There's lots of stuff we did with it. Okay, so coming back to operator overloading. Well, some languages including Python make it possible to have different meanings for the same operator when applied to different types. For example, the plus in Python makes quite different things for integers, means quite different things for integers and for strings. This feature is called operator overloading. It is especially useful when programmers can also overload the operators for their own user-defined types. For example, let's add the method add to our point class, and note the special way I'm going to write this method, again within two double scores. So you should probably get a hint from this thing why we rewrite things in underscores and all. We certainly want to overload the operators using our own functions. Okay, so it takes the default self parameter and the other, so it's going to invoke, it's going to add the two point objects, and it's going to call in one and we'll add the other to it. So what it does, it returns a point object, and the x coordinate of that point object is self.x plus other.x, and the y coordinate is self.y plus other.y. Pretty easy to understand. So as usual, the first parameter is the object on which the method is invoked. The second parameter is conveniently named other to distinguish it from self. So now you can say like you want p1 is a point, and I want to write it's a point 3,4, p2 is a point 5,6, and now I want to print what is p1 plus p2. I hit F5, so I get x is 8 and y is 10. So 3 plus 5 is 8, 4 plus 6 is 10. So as an exercise, you can also try to add the subfunction that overloads the subtraction. Okay, so there are several ways to override the behavior of the multiplication operator by defining a method named mul or rmul or both. So if the left operand of the multiplication operator is a point, Python invokes the mul function, which assumes that the other operand is also a point. So it computes the dot product of the 2 points defined according to the rules of linear algebra. For example, let's have a def mul, again self and other. So this time the multiplication will be a vector multiplication. So this is self.x into other.x plus self.y into other.y. So if the left operand of the star operator, the multiplication operator, is a primitive type, let's say an integer, and the right operand is a point, then Python invokes the rmul, which performs scalar multiplication. So you have the rmul, and this is again self and other. So what it does, it returns another point object with the other into self.x as the x coordinate and other into self.y as the y coordinate. Okay, the the result of this is a new point whose coordinates are pardon me, the new point whose coordinates are a multiple of the original coordinates. If other is a type that cannot be multiplied by a floating point number, then RMUL will yield an error. For example, that we have these 2 points, and now I'm going to write print first P1 into P2. Let's see what it prints. It prints 39, which is 3 into 5 plus 4 into 6. And the second thing I'm going to do is I'm going to print 2 into P2. So, and it's 10 and 12, which is 4 into 2 and 6 into, which is 5 into 2 and 6 into 2. So 10 and 12. Okay. But what if we try to evaluate P2 into 2? Well, since the first parameter is a point, Python invokes the mul with 2 as the second argument. So inside the mul, the program tries to access the x coordinate of the other, which fails because an integer has no attributes. So if you try to print, P2 into 2. So it says int object has no attribute x. Okay. So unfortunately the error message is a bit opaque. This example demonstrates some of the difficulties of object-oriented programming. Sometimes it is hard enough just to figure out what code is running. See, int object has no attribute x, so you wouldn't be able to, I mean, if somebody else's code shows this error, then you might have some trouble understanding what really is happening there. Okay, so let's go to the topic of inheritance now. And the language feature most often associated with object-oriented programming is inheritance. So inheritance is the ability to define a new class that is a modified version of an existing class. The primary advantage of this feature is that you can add new methods to a class without modifying the existing class. It is called inheritance because a new class inherits all of the methods of the existing class. Extending this metaphor, the existing class is sometimes called the parent class. The new class may be called the child class or sometimes the subclass. So as an example, we are going to take a new file. It's called 817.py. Okay, first up I'm going to write a class animal. Okay, so an animal can speak, and I have a speak function which is not implemented. So I'm going to raise an error, and we're going to talk about the errors in another class. For now, just understand that if some method raises an error, not implemented error, so when you try to invoke the speak function on the animal, this exception will be thrown that it's not implemented, and that's a high level understanding of errors. Now I'm going to write speak twice. Speak twice just invokes self.speak 2 times. Alright, so the next function is, okay, let's have a new class, and I'm calling this class a dog, and the in brackets I'm going to write animal. So dog is now a subclass of animal, or the dog class extends the animal class. So the advantage is that in the dog class I don't have to implement the speak and speak twice functions again, because these are already part of a general animal. A generic animal can speak twice. So I don't want a dog to be speaking I don't want it to implement the speak function again, because being a general animal, a dog has the ability to speak. But let's say I want to, since in the general animal, in the generic animal, I have not implemented the speak function, or I have implemented the speak function which just throws an error, it's equal to not being implemented. I say that whenever we call speak on a dog, it prints woof, woof. Okay, and I'll write a weight function that every dog is gonna weigh 100 pounds. Oh, it's just my way. Okay, now write another function. Now write another class, and this is the cat class, and this again it extends the animal class. So here the speak function, probably know what I'm gonna type right now. It's gonna be meow. That's kind of lame. It's okay. Works. And the weight, and I'm gonna say every cat weighs 50 pounds. Rather than print, I should actually say return 50 pounds. And here again, I'm gonna just, okay. So now we say D is equal to a dog and C is equal to a cat. If I say that D dot speak, D dot speak is woof. Says none as well. Where is this none? Where is this none coming from? Don't know. Anyway, so the advantage you have is going to be evident in the next example. Okay, print expects an argument. D dot speak didn't actually return anything, it just printed a goof. So that's why I just want to convert all of these prints to a return. Okay, so now I do F5 and say the advantage of inheritance is that the speak twice function, I don't have to implement any. So I implemented the speak function for a dog because I wanted to implement the woof sound again. Okay, but speak twice function I don't want to implement for all the animals, because in the speak twice function I am just calling the speak function twice. So if for a particular animal the speak function is already implemented, it will just call the speak function twice and the job is done. For example, if we now say that D dot speak twice, now it will print. Okay, what's this now? Okay, so the advantage you're gonna see right now is when I say speak dot twice, and in speak dot twice I'm calling speak 2 times. So if I hit F5, it says a woof and a woof. Actually I don't need to print it since I print it, so I get a woof. The advantage of inheritance is that, let's say you want to have a class which has some common functions, and then you have some specific kind of a class which has the functions of the generic class as well as some specific features on its own. Let's say you want to print the D dot weight. Weight function is specific to the dog class, but the speak twice function is common to all the animals. So through the means of inheritance, you are actually saving repeated code. You don't actually have to implement this piecewise function again. Now if you do F5, it says 100 pounds, and similarly for a cat you can write c.weight, and c.speak twice will c.speak twice will have a meow printed 2 times. Okay, so guys, that's all about the inheritance, and with this topic we end the discussion on classes and objects, and next time I'm going to be seeing you around with files and modules, and after that a lecture on inheritance, exceptions and errors, and then we're going to be done with the course. So guys, take care, keep up the hard work, see you around.